had some good conversations. Did you all have a good conversation?
Yes.
Yes. Swap some business cards? Make some business? Yes? Good stuff. Well done. Thank you very much. Up next we have Bobby from Cloud. And with that I will hand it over. There you go, Bobby. Thank you.
Oh. Look, so before I get started, I just wanted to touch on something that I've been seeing a fair bit of on Hacker News recently. Does anyone else here check out Hacker News? Anyone? A few people? So for those that are unfamiliar with it, Hacker News is sort of like the Reddit for all IT news, everything from app dev, IT security, cloud infrastructure, the works. So if you're looking for a one-stop shop for all your news, definitely check it out. Anyway, I wanted to throw up a couple of headlines that I've been seeing a fair bit recently. Artificial intelligence and automation will result in reduction of IT service staff by 7 to 10% in India and the US by 2022. 56,000 layoffs and counting. This was from the end of last year. India's IT bloodbath this year may just be the start, and India faces youth unemployment spike as automation threatens traditional jobs. Now, when I was first entering the IT workforce, it was obvious that there was kind of this trend of outsourcing to offshore. And now, well over a decade later, we're seeing the same sort of jobs get outsourced, but this time to machines. And there's a common theme throughout these headlines of automation. But as system administrators, we've been writing scripts for quite a long time now. Automation is nothing new to us. So what's changed exactly? Why is it suddenly such a hot topic? So you may have heard of the phrase, the democratization of AI, and it's been thrashed quite a bit recently. The general thought is that this is the general driving force behind automation across all industries, not just ours. And you see this, on the news, people complaining about losing their jobs to robots and the like. And so the general idea of it is that it's about making AI capabilities available to every application developer in a simple way so that they can integrate it into their application to solve complex problems. I guess you see, you start to see a lot of this. There's two main factors in this. One is that it's offered by the cloud, so you no longer have to have compute power on-prem to power this capability. And the other is that you no longer need to have a deep understanding of neural networks and machine learning to take advantage of them. And we're starting to see this with some of the major cloud providers releasing hosted machine learning capabilities. Obviously, on this slide, we've got a couple of services provided by Amazon in this space that cover image recognition, natural language processing, and the like. What I wanted to do today was essentially take one of these hosted machine learning services and show just how easy it is to use it to solve a common IT problem with no prior machine learning experience or knowledge. And that common problem, it's kind of already been solved, but it's the password reset for the service desk. So for those of us that started our career on the IT service desk, we'd be fairly familiar with this, with this request and with requiring an account to be unlocked. What if we could create a chatbot that we could speak to, via voice or over text, and it could verify our identity and essentially reset our password for us? Not only would we be saving on headcount costs, but we'd be streamlining the user verification process. So what would this look like at a high level? Before I get started, I didn't actually see the hands before. Has anyone had a chance to play with Amazon Lex at all? Yeah, so a few people. What about Amazon Connect? A few people. And AWS Lambda. I expect a lot more people. Yeah, cool. Alright, so we'll step over each component one by one. So in our scenario, it begins with the user calling the service desk, and in our case, when they call the service desk, they're hitting Amazon Connect. Amazon Connect is a cloud-based contact service center solution that can be provisioned in Amazon within your Amazon account, quite simply with a few simple clicks. It's a pay-as-you-go. There's no upfront costs. There's no contracts to be locked into. The thing that I really like about Amazon Connect is that you can plug in other AWS services. So for instance, you could potentially plug in AWS Lambda, and you can do some compute to work out that the number belongs to someone that you've got stored in a database, and you can provide them a personalized greeting. The thing that we'll probably be focusing on most today is that you can plug in Amazon Lex, which is an AWS service that you can build conversational interfaces with. You can converse via text or via voice, and it leverages natural language understanding and automatic speech recognition. So you can have this natural dialogue with users. So when the user calls with their request to have their password reset, essentially they request that, and Amazon Lex detects that they've requested this and begins this dialogue with the user to ask a number of verification questions. In our case for this demo, it's specifically their user ID, their date of birth, and the month that they started. Once Amazon Lex has collected this information, it passes it off to AWS Lambda, which does some processing to determine that the user is who they really say they are. And to do this, it compares it to our source of truth, which is the user in Active Directory. Assuming that the attributes match up with what the user provided and what's stored in Active Directory, we reset the password in Active Directory and we send it to the user via Amazon's simple notification service. And that sort of completes the workflow. You can see that there's no running instances in this workflow, so essentially you're not paying for anything while the environment runs idle. So diving a bit deeper into Amazon Lex, as we described before, it's a AWS service used for building conversational interfaces. No prior deep learning knowledge is necessary, and this is an important factor that allows us to sort of leverage this capability without too much ramp up. It's the same conversational engine that Alexa uses, which you guys will be pretty familiar with. And essentially, it's quite easy to get started. You provision your bot in the console and you start to dictate the sort of flow you want it to take. So in this example, we can see the user administration bot. And because the slide is only so big, I fit in two potential requests that could come in. A chatbot can have one or more requests stated. And so for this we've got two, which is the reset password request and the unlock account request. Now a request in Amazon Lex terms is called an intent. And an intent is invoked when a user states an utterance, which you define per intent. So essentially an utterance can be, I forgot my password, or I need my password reset. You would specify this in Amazon Lex per intent. And then when the user states their request, they don't have to state that in the exact words. Amazon Lex, using its natural language understanding, will be able to determine, right, that what the user said is more or less the utterance that's associated with the intent. Once Amazon Lex has detected the intent of the user, it then issues a prompt, or more than one prompt essentially, to collect information from the user which is required to fulfill the intent. In our case, it will be asking what the user ID is. It will be asking what the date of birth is, what the month started is. This information is then collected and stored in slots. And you can think of slots like variables. And each slot has a slot type, which is very similar to a variable type, like an integer or a date type. I guess the difference with Amazon Lex is that you can be quite specific about the slot type. So Amazon provides pre-built slot types such as actor, movie, city, airport. And it's quite important that we use the correct slot type, so we're really, I guess, plucking out or working out what the user is what we're trying to capture from the user. So for instance, if the user says, my user ID is 123456, we want to ensure that we're only capturing the user ID and not the rest of the sentence, regardless of how it's stated. So the slot type really allows us to zone in and pluck out the information that we require. Once we've been over multiple prompts and slots to collect all the information we require, we reach confirmation, which is where Amazon Lex basically confirms with the user that the information collected is correct, gives us a chance to change it if we need to, and then finally we move to fulfillment, which is where Amazon Lex essentially invokes a process based on the information gathered. So you guys at the back probably won't be able to see this. In fact, people at the front probably won't be able to see this, but it's essentially a JSON event that's passed from Lex to the AWS Lambda function. And you can see this is the structure to expect out of Lex. Whenever Lex is sending any information, it's within this sort of format. At the top, we've got slots dictated. You can see the date of birth, the month started, the user ID. A bit further down, you can see the slot details, which actually state the original value that was provided by the user, so whatever they stated. In our case, when they said 14th of April 1983, they stated it in the exact words, and then that was converted to a date type. A bit further down, the output dialog mode. This dictates the way that the user is interacting with the bot, whether it's text or whether it's voice. And this is important mainly because if it's voice, we may want something to be said by Lex in a specific way. And to exemplify that, when we look at a sentence which states that my user ID is 123456, we understand the context of that number and we read each digit individually. But Lex doesn't understand the context of that number. Therefore, we can use speech synthesis markup language, which is essentially a markup language, to dictate to Lex to state each number individually, rather than to read it as 123,456. Finally, we have the session attributes field, which basically stores information for the duration of the chat session. So with our Lambda function, essentially, we follow a workflow. My favorite runtime is Python, and that's what I choose to essentially code in. Python obviously doesn't have any LDAP capabilities out of the box. We need to use a module for that. So in our Lambda function, we're leveraging a LDAP module to talk to Active Directory, and we're leveraging an Active Directory service account that's been pre-created. It has access to read user attributes within a specific OU that we want it to have access to, and the ability to change the password attribute for users. That account is stored as an environment variable in our Lambda function, and we're encrypting the password with KMS so that only the Lambda function has the ability to decrypt that password. We perform a secure LDAP bind in our Lambda function when it's invoked. We query Active Directory for the relevant user attributes. It's worth keeping in mind that the user attributes that are defined with date of birth and month started aren't default attributes in Active Directory. They're predefined custom attributes, so we've modified the schema. We compare the slot values that have come from our Lex chatbot and from Active Directory. And if they match up, we reset the password, send it via Amazon's simple notification service. If they don't match up, then essentially we provide an access denied message. If we were to run something like this in production, we would probably have more factors of verification. We could potentially take the user's mobile phone number from Amazon Connect and use that as a factor of authentication. And we'd also probably want to ensure that someone's account is only attempted to be reset once or twice. We definitely want to monitor that so this can't be used as an angle for brute force. So technically we could stop right there. We've got a working chatbot that you could build into a mobile application. You could build it into a web interface that's accessible to users. However, what about our more traditional users that are used to picking up the phone and calling someone and asking for help? So this is where Amazon Connect comes in. And as we mentioned before, it's an AWS service that's basically a virtual contact service center solution. It has the usual things that you would see in a contact service center solution. So you can manage agents, you can create contact flows, you can track performance metrics, and it's really quite simple to get started. It's just a few clicks in the console, and you assign a phone number to your Amazon Connect instance, and off you go. The next step is actually to create a contact flow, which is exactly what you see here. It's a bit blurry once again. Sorry once again to the guys at the back, you wouldn't be able to see it. But what you're sort of seeing here is exactly the contact flow designer for when you're basically creating the experience you expect your users to have when they call in. So it essentially looks like a flow chart. The user enters on the left-hand side, reaches the first block. They're provided with a default greeting, or it could be a customized greeting. And they're simply stated to state their request. It's no more having to listen to press 1 for this, press 2 for that, like a traditional IVR. The user is asked, what would you like assistance with today? If they ask to have their password reset or their account unlocked, they're serviced within that block. If they're asked to be transferred to an agent, or the Lex chatbot doesn't understand their request, then it would naturally default in an error. And we actually route any errors or transfer agent requests to, in that screenshots, to my mobile, but you would be able to transfer it to a human queue where you have a human operator sitting there waiting for the calls that you haven't picked up with your Lex chatbot. So this solution allows you to offload some of your very common calls that you can solve via a simple process, and then be able to handle the less common calls by a human operator. And the great thing about Lex is that you once again are able to take advantage of horizontal scaling in terms of being able to burst out those sessions. So if you have 10 users calling in at the same time, and they all need to have their password reset, Lex handles this in 10 sessions horizontally, all happening concurrently, which is very different from if you only had one user on the service desk, they'd all have to wait in turn. So what I wanted to do was actually show a demo. I don't know how to work on a Mac. I can build the chatbot, but I can't. No worries. Are we able to turn up the? So before we actually show the demo, there's a couple of things worth noting. So we're basically going through an example of what it would be like if a user called the service desk. We're using the Amazon Lex console mainly because I wanted to show the response that Lex provides when it understands an intent and when it starts collecting that information. I purposely give the incorrect date of birth, and I give it in a date format that exemplifies how Lex is able to understand what I've said and convert it to what it believes is the date. That's the one. I can't remember if there's anything else. Oh yeah, and there's an example of SSML on there, but chances are you guys probably won't be able to see it. But yeah, let's give it a shot.
Hi there, I've forgotten my password. Just wondering if you can assist.
Sure, I can help with that. But first, I need to verify your identity. What is your user ID?
My user ID is 123456.
What is your date of birth?
My date of birth is next Thursday.
What month did you start?
I think I started in April.
Just to confirm, your user ID is 123456. Your date of birth is February 8, 2018, and the month of your start date is April. Is that correct?
Actually, my date of birth is the 14th of April 1983.
Just to confirm, your user ID is 123456. Your date of birth is April 14th, 1983, and the month of your start date is April. Is that correct?
Yep, that's correct.
Your password has been reset and sent to your mobile.
Cool. So, look, that's pretty much it. Does anyone actually see any use in something like this within the workplace? Can they think of any sort of use cases that they might be able to use something like this? Maybe not the connect part, but the Lex part. I don't see any responses. Cool demo. Yes. Yeah. Okay. So it's worth noting I have no prior machine learning knowledge, and that took a week to spin up. So it's really simple to get started. And if you have any sort of ideas of potentially implementing something,
And you don't know how to use a Mac.
yeah, and you don't know how to use a Mac, that's not
There's hope for
required.
us yet.
There's an implementation guide on Cloud's blog, Cloud with a K. It's a 4-part blog that I've written, which basically builds this bot, but it provides a pretty good foundation if you essentially want to build a bot that services pretty much any service. It'll take you through the foundations that are required. Alternatively, you can reach out to me on LinkedIn or shoot me an email if you have any questions, or if you have any questions now, I can answer them.
Bobby, I know that AWS covers some languages. Do you see some scope for sort of global type organizations to do this, where it recognizes some differences in languages?
So, as in verbal languages, yeah. So the question was, is there possible scope to be able to use this capability in different languages, not programming languages, so human languages. So my understanding is currently the capability is only available for English. That's from memory. Last I read, it was only available for English.
Mitch, do you have any ideas?
That's great.
Yeah.
Yeah. An AWS guy here to fact checking me. Anything else? All good. Otherwise, you can come see me afterwards. You can have a chat. Very good. Cool.
Cool. Bobby, that was awesome. Thank you very much. So next up, we're going to do the prize draw. Which one are we doing first? Which one are we doing first? Doing the green bucket? Okay, so I have to own up here. I forgot to bring the dot. It does exist though, so it's still available. I just forgot to bring it. So if you do get it, just make sure, and we will post it to you, I promise, or we'll arrange to meet you somewhere. But hands up now, I forgot to bring it. Apologies, but it does exist, I swear. So we'll do the beats speaker first. So Gary over here, so you're going to do a draw? Or? Oh, this is it here. So where, Michael, do you want to sort it out?
Thank you, guys.
Do you want to say?
Yeah. Look, thanks, guys, for the just smash the pointer. But look, thanks for having us. It's been a great introduction to the AWS User Group from Palo's perspective. Hope you learn a lot from Mauricio. We'd love to be back again. And thanks for your interest. Could I, before I do the demo, before I do the draw, could I just get a show of hands with regard to how many companies out there are using Palo Alto networks in your environments?
2, 1, 2, 3, couple. Whoa.
Too expensive.
Value for money, I say.
It's like $1.50 an hour.
Exactly. Okay, guys, so we've got a quick draw for a Beats Pill speaker. So, has everyone filled in their eval forms? and thank you for doing that. I was going to pull someone out of the audience, Mr. Value for Money.
And this is completely objective because I do not have the form.
Nice. Nice. So if you can just pull one of those rabbits out of the hat. Thank you very much. And it is...
It's too expensive, that's why.
Karen or Karen?
Redraw.
Karen Shum.
It's me.
What's your name? What's the pronunciation?
Carve.
Carve, I'm sorry. God, I'm great with names. Carve, congratulations.
I need to check my with ex-boss. Is it okay? Because I'm ex-policy.
Yeah, you don't work with us anymore, so
Okay.
it's definitely not next.
Nice
There
one.
you go. Thank you.
Thank you. Cheers. I'll let you draw this down because you can apologize.
Good stuff. All right. Okay. Cool. I'll go there. No, I get somebody there to pull it in.
Thank you. Thank you. Cheers.
Thank you very much to Palo Alto tonight for putting that on. It's much appreciated.
Thank
Good
you.
stuff. Thank you. And Freddie Lou. Freddie Lou. Are you right? Hey, Freddie. Hey. Congratulations. Sorry, yes. There's a dot. We just get your details and we'll put it. Where you were? Somewhere you from? Yeah. Office. Multi-cloud. Yeah. We're in Sydney, North Sydney. Whereabouts? Cool. And did you enjoy tonight? Yeah. Lovely. Yeah. Cool. Excellent. Thanks, everyone.
Thank you, Paul.
Thank you, everyone. Thank you for coming this evening. We'll see you in a month's time. Same place, same time, same place. 7th of March. All right. Thank you. Take it easy.